Okay, let's go for video number 2 today. Hopefully you were able to go through the first one. Again, I'll answer any questions that you might have tomorrow. Part of the directions that I had left were for you to play around on the GeoGebra like we did yesterday, and so we can come up with some sort of definition of a radian. For right now, I'm going to leave my space blank so we can fill that part in together, but you just have to come up with it in your own words. What happened with the diagrams? Okay, in regards to this radius right here and the length that it became as part of the circle over here. Okay, so first question is, how many degrees are there in one full rotation? I think we answered that yesterday as well, and we'll say that's 360 degrees. How many radians were there in one full rotation? So there were 2 pi radians, or on the screen you might have gotten a number that was close to 6.28. Okay, I should say about 6.28 because depending on your finger you might not have gotten that exact number, but something really close. I'm hoping that you notice that 6.28 is twice 3.14, and pi really represents 3.14. So if we're talking 360 degrees, then that's 2 pi radians, which is a complete circle. Okay, so I know that the length over here represented by S has something to do with that 2 pi radians, right? It's a section of the circle. Okay, exercise number 1 says consider 1/2 of a full rotation. So if a full rotation is 360 degrees, then half of it should be 180 degrees. And if a full rotation was 2 pi, then half the rotation should be 1 pi radians. Hopefully that makes sense. Part B says to use the equivalent angles of a rotation in part A, and let's convert 30 degrees into an equivalent angle in radians. Okay, so I'm not there to go through the discovery of this, so I'm going to tell you how to convert it, and then we can work on the discovery piece or backtrack if you want to know where it came from or why it came from tomorrow. The formula is on the reference page, but if I have a degree and I want to change it into radians, I'm going to multiply it by pi over 180. Okay, so the pi over 180 is on your reference page. It's on the left-hand side, so look in the front of your, oh, you don't have a packet, but I'm sure you have a reference page. I will give you one so that it's handy for you. Okay, so 30 times pi over 180, either I'm going to multiply it by myself or I'm going to let the calculator multiply it. If I put it in the calculator, I'm not going to put the pi in the calculator because my calculator is probably in degree mode and pi represents radians. So if I use my fraction rules, I will just get 30 pi over 180, and I can reduce the 30 over 180 to get 1 pi over 6, or I'll say that's 1/6 pi. I probably will write it like this. It's easier, but it's fine if you write it as 1/6 pi. Okay, so it's just a mechanical thing that we're going to have to practice. Take a degree measure, convert it to radians, and multiply it by pi over 180. Okay, here's the mechanical practice. Convert each of the following angles into radians. So to convert into radians, we're going to multiply by pi over 180. Remember, when you're multiplying fractions, we multiply across. So this is 90 pi over 180, and I will reduce that to pi over 2, or maybe you would write it as 1/2 pi. That's up to you. It's the same thing. Okay, I think that makes sense, or at least it does in my head. So if 180 degrees was 1 pi, half a circle. Then 90 degrees would be half a circle divided by 2, right? Basically a quarter of a circle, okay? So this would have been a quarter of the circle. So a quarter of the circle, which if we represent over 2 pi, a quarter of 2 would be 2/4 or 1/2. Okay, don't worry about the little conversion. You can just stick with mechanics if it's a little easier. So changing from 120 degrees, I multiply by pi over 180. I get 120 pi over 180, and then I'm simply going to reduce the 120 over 180, and that's 2 pi over 3, or 2/3 of pi. 225 multiply by pi over 180. I get 225 pi, divide by 180. Reduce on my calculator if you can't do it in your head. They're both divisible. They're both divisible by 45, but if you can't do it in your head, then it becomes 5 pi over 4. Okay, if that was too fast, or if I'm speaking too fast, press pause so that you can write it down, and then press play to go on to the next question. Okay, I'm trying not to make the video so long. Okay, now for number 3, we want to convert from radians into degrees. So from degrees to radians, we multiply by 180 over pi. But to go from radians to degrees, we're going to do the reciprocal of that, and I'm going to multiply by 180 over pi. I do believe on the reference page, you get the formulas. So here they are on the reference page. So if I want 1 radian and I want to go make it into degrees, I'm going to multiply it by 180 over pi. If I have degrees and I want it to be radians, then I will multiply it by pi over 180. Okay, so in this case, I have 5 pi over 6 radians. And so I have 1 radian is 180 over pi, but I have 5 pi over 6 radians, so I'm multiplying it by 180 over pi. Okay, so if I have pi's and I multiply, remember when I reduce fractions, if I can reduce on the diagonal. So if I'm trying to put something in degrees, the idea is to get rid of the pi's, and they should be on the diagonal. That's kind of how I know if I should put it on the top or the bottom. So 5/6 times 180 is what I'm going to enter into my calculator, and I get 150. I really would rather not put pi in my calculator ever if I can avoid it. Most of the time it's in degree mode. I can keep my calculator in radian mode. We'll talk about that in the future. However, it's going to estimate for you, and I don't know if you want to estimate. So we do a quick calculation off on the side. So theta is 3 pi over 2. I want it in degrees, so I'm multiplying by 180 over pi. Now, I could put the entire thing in my calculator. The calculator will know to reduce these. So if you forget, it's not a big deal. Okay. So I end up with 270 degrees. Okay, so last one is 3 pi over 4. And I'm going to multiply by 180 over pi. And I end up getting 135 degrees. So again, if I'm going, ooh, sorry, it's off on the side, so I'm going to leave it there for just a moment. If I am speaking too fast, then just please pause it and come back to it when you get a chance to copy it, okay? And I will answer any questions that you might have tomorrow. Okay, gonna flip the page. Okay, so we're also want to make sure that we feel comfortable with radians don't always have a pi, right? So if I want to go from radians into degrees, I'm going to radians into degrees, I'm going to multiply by pi over 180. Okay, so 5.8, I'm going to multiply by 180 over pi. Now in this case, I'm going to have to enter into my calculator, right, because I can't multiply that by myself, and it's telling me to round it to the nearest degree. So I'm going to go ahead and calculate that. 5.8 times 180 over pi, there we go, 5.8 over 180 over pi, and it looks like I have 332 degrees. Okay, so 332 degrees. Multiply by 180 over pi, type, and this time I'm going to get 241 degrees. Multiply by 180 over pi, right? Just a mechanical skill. Change from radians into degrees. So multiply, calculate, and I end up with 143 degrees. Now, keep in mind that if this is a multiple choice question and the answer that you're looking for isn't there, it is possible that its coterminal angle might possibly be the choice, even because it's the same angle. Okay. Okay, last question of the day. An angle drawn in standard position whose radian measures 2 radians is going to terminate in which quadrant? So if it's 2 radians, you do not know enough about radians to think in terms of radians. Soon, in a couple of weeks, you'll be much better at thinking in terms of radians, but even now, you will probably always convert to degrees. Okay, there'll be some radians that you will memorize because we use them a lot, but most likely you will have to think in terms of degrees. So I'm going to multiply it, and then I'm going to type. Okay, 2 times. I'm literally going to put it in my calculator exactly the way that I see it. I see it's 115 degrees. I'm comfortable with 115 degrees because I know that is in quadrant 2. Okay, you have enough information. You can practice the next page, which is just conversions. There's a few word problems at the bottom of the page. Actually, maybe I deleted them. No, there's a few word problems at the bottom of the next page. So I will take a picture. Don't worry about the word problems. We will go over them together. Okay, I will see you tomorrow.